Good morning student. In this session we will take problem design of helical coil spring. Let us have problem. A closed coil helical spring is used for an automobile suspension system. The spring has stiffness 85 Newton per millimeter square with square and ground ends. The load on the spring causes a total deflection of 9 mm. By taking permissible shear stress of 400 megapascal, find first wire diameter, second length of spring. Take spring index is equal to 6 and modulus of rigidity G is equal to 80 into 10 raised to 3 Newton per mm square. Now design of spring means determining all the parameters required for manufacturing the helical coil spring. Means required data is wire diameter, mean coil diameter or outside diameter, inside diameter, pitch, solid length, free length and number of turns, total number of turns. If we are determining these values, then we can manufacture the spring. This is the list of formula from which we can determine all these parameters. C is equal to capital D upon small d. This is Walls factor, that is equal to 4c minus 1 upon 4c minus 4 plus 0.615 upon c. Tau is equal to k into 8wd upon pi d cube. Delta is equal to 8wd cube into n upon gd raised to 4. Solid length is equal to ls is equal to n dash d. Free length is equal to ls plus delta maximum plus 0.15 into delta maximum, and pitch is equal to lf upon n dash minus 1. So by using this formula we can determine different parameters. This problem, C is given, that is equal to 6. Stiffness S is equal to W upon delta. From this formula we will calculate the actual load W, that comes out to be 765 Newton. Now we will calculate the Walls factor K from this formula, putting the value of C, that comes out to be 1.2525. Now from this formula, transferring d, small d on one side and known quantities on right hand side, this formula becomes like this. Putting the value of W, C, K and tau, the wire diameter comes out to be 6.0497 millimeter. Now from this formula, C is equal to capital D upon small d, we can calculate the mean coil diameter, that comes out to be 36.29 millimeter. Now from this formula, transferring n on left side and other quantities on right hand side, this formula becomes like this. Now putting the value of values of delta, G, D, W and C, the n comes out to be 3.29. so we will take say 4 turns, n is equal to 4 turns, active number of turns comes out to be 4. Now for square and ground end, total number of n dash is the total number of turns, and total number of turns comes out to be the summation of active turns plus 2, means n plus 2. So n dash comes out to be 6. Now from this formula we will calculate the solid length ls, putting the value of n dash and d, that comes out to be 36.2982 millimeter. Now from this formula, lf is equal to ls plus delta maximum plus 0.15 into delta maximum. Putting the values of ls, delta maximum, the lf comes out to be 46.648 millimeter. Now from this formula, putting the value of free length n dash, we can calculate from the calculator the value of pitch, and putting the value of mean coil diameter and wire diameter, we can calculate di and do also. So this is all about the design of spring. This is the end of the session. Thank you very much.